so if anyone has sort of no idea what's going on here, we are recording a live episode of Astronomy Cast. Specifically, we are recording a catch-up episode of Astronomy Cast. So when I start up this episode, you're going to hear me say that it's episode 303 from Monday, April 22nd, and that's because
it's not April 22nd.
It's not. It's because we're about 8 weeks behind. So
it's June 2nd.
It is June 2nd. So we've got about 6 episodes to go to catch up after this, and we're going to be getting a big chunk of them done today. No, sorry, this week, not today. And then we're going to get a bunch more done to kind of get ahead because you're going to be gone in July. So
yeah.
So we've now got our good buddy Courtney is sort of whipping us into shape, making sure that we sort of are able to manage our schedules.
At even if Miss Array.
Yeah, even if it's at very strange times. So yeah. All right. So
if you ever want to traumatize Fraser, show him my calendar.
Yeah. She's like, I'm going to share my calendar with you. And I was
well, you were proposing all of these things, and I
know. And now you just shared me your calendar, and I just stared at it in shock horror and just cried. Oh, it's madness.
No, madness was the tornado on Friday.
Yeah. Okay, cool. So let's. Are you in mono-ish?
No, that would have been intelligent.
Okay. Yeah, and if you want to post any comments, questions, feedback, we can probably answer some questions afterwards, although I will probably have to go run and parent after this. So yeah. And so this is probably going to be a very short episode. In fact, probably a lot of these sort of one-offs are going to be short episodes.
But we will be caught up.
Yeah. Which would be great. Everybody will be happy. Nobody will be mad. Somebody wrote a really sad review on iTunes. It was like something, They gave us 1 star, and they're like, because of our bad schedule, we've destroyed all of our credibility and goodwill that we've built up.
We do this for free.
I know. Refund in the mail. I sent him his refund. Okay. Are you in a state of...
I'm waiting for my thing to rename it so that I don't copy over what we did earlier.
Probably best.
Yes, it's working on it.
It's 303.
Yes, that was what I was correcting.
Good.
Yeah. No, it's for those of you who don't know, this is something I was sharing with Fraser before all of this gets started. We've reached the point of internet celebrity, which is not the same thing as real celebrity, because real celebrities get paid.
Right.
We've reached the stage of internet celebrity where we're getting, hey, will you donate to our Kickstarter? I even had one friendly soul who had clearly no understanding of what state university professors are paid ask if I would help buy him Google Glass. And no, we do this for free, and neither of us have well-paying jobs. Fraser is a journalist. I'm a state university professor. So unfortunately, our need to occasionally earn a living gets in the way of our recording.
Yeah, exactly. Yeah, and it really does. I mean, if we've got to buckle down and get through the work that pays the bills, that's what we have to do.
Yeah. But I now have GarageBand happy.
Oh, good. Okay, so you're ready to record?
I am.
Okay. Let's get this party started then.
Okay, I'm pressing record.
I am also pressing record. All right? Can I start?
So? Yes. Okay. You're good.
All right, here we go. Astronomy Cast, episode 303 from Monday, April 22nd, 2013. Equilibrium. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hi, Pamela. How you doing?
I am doing well, but my recording just stopped.
What? I have to do this again?
I'm sorry.
Okay, I'm ready. Should I stop my recording?
Yeah. I apparently have more things open than...
Audacity!
Audacity really hates me.
It is awesome on every level. It
no.
rules and never breaks, and it just...
It never breaks for you. It always breaks for me. You
breaks
have
towards awesome.
you have special audacity skills.
Is that what I have? Mad audacity skills?
You have mad audacity skills. I have audacity break skills. Okay. I think the fundamental problem is my hard drive is fuller than it would like to be. So I'm going to delete all of the things that it's sad about and empty my trash.
World hunger.
I wish I could delete world hunger. Wouldn't that be awesome?
Yeah. Oh,
put world hunger in the trash. I wish I could do that. Empty trash. Oh, good Lord. I had apparently 11,000 items on my desktop.
How is that even possible? Okay.
I don't know. Okay, I'm pressing record again.
I am also pressing record.
Wow, it's moving zippy now. Okay.
Okay, all right.
Apparently having 11,000 items on my desktop. Didn't like that.
Okay, let's rock. Here we go. Are you ready? Can I do this now? Are you recording?
Yes,
is it in mono?
You can. Yes.
Yes? Okay.
It is in mono. Yes.
All right. Astronomy Cast, episode 303 for Monday, April 22nd, 2013. Equilibrium. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. So let's give another shout-out to the upcoming Astronomy Cast Mad Marathon.
Well, and CosmoQuest.
Sorry, the CosmoQuest, Mad Marathon.
It's the hangout-a-thon.
Yep. 24-hour hangout-a-thon, maybe more. Why maybe more? Wasn't 24 hours enough? And then someone thought, well, we should do 36 because records seem to be broken.
What we're finding is there's lots of awesome people who want to support us and help raise money. And so we want to give everyone a chance to say their piece and give us their money. That came out more bitter than intended. But it's one of these things where I'm watching fly by on my Twitter feed news about the U.S. president's upcoming budget. And if the budget goes through as written, most of the field of astronomy science education that works on anything outside of the National Science Foundation that's federally funded gets defunded, which is a euphemism for we're all out of work.
Right.
So failure is not an option this time. We need to raise the money to keep all of our projects going, and if we're able to surpass our goals, that will allow us to hire other people that are going to be unemployed 4 months from now if these budgets go through.
Right. All right, so 36 hours is just a further demonstration of your willingness to suffer in the name of space and astronomy.
I've worked longer than that before when we had software bugs.
I think you've been up for 36 hours right now.
It feels like it.
Okay, cool. Well, let's get rolling with this episode then. So what's the date, in case people want to put that in?
It is June 15, 16. We are starting at noon Eastern and going at least until Sunday at noon Eastern and possibly until midnight.
Fantastic.
Eastern.
All right, and I'm going to jump in at some point, and I know various of our other space friends will be sort of showing up as well and putting on a show. So hopefully this will keep everyone entertained and keep the donations rolling. All right, so many of the forces in space depend on equilibrium, that point where forces perfectly balance out. It defines the shape of stars, the orbits of planets, and even the forces at the cores of galaxies. Let's take a look at how parts of the universe are in perfect balance. So, I put this on the roster, and I don't remember why.
Well, admittedly, the list of ideas was from May 2012. So it's been a while.
I tend to I've sort of brainstorm them, 50 or 60 episodes in advance and sort of throw them out into the show notes, and then you pick and choose from what you like. But I think we both got kind of intrigued by the topic, and then we're like, well, what does that mean to us?
Right.
And
I went, what type of equilibrium is it?
I'm talking about the band. It's a German folk metal band, and I'm a huge fan. There's also a 2002 science fiction movie about equilibrium. But no, I mean, so what is the classic concept of equilibrium?
Well, Basically, it's anything that's balanced. You can have a chemical equilibrium, which is where you have balanced numbers of reactants. You can have gravitational equilibrium, otherwise known as a balanced seesaw. It's any time that the forces or chemical reactions or whatever it is balanced so that nothing is accelerating, changing, slanting, or any of those other things that lead to a state change.
And I can remember being in high school and, when we learned the whole section on forces and being quite surprised at how, when you're standing on the ground and you're pushing down on the ground, that makes sense. But in fact, there is a equal and opposite force pushing up from the ground. And the reason that you're not either flying out into space or sinking into the ground is because the forces on your body are in equilibrium.
And when you're sitting, all the different muscles that are in place. One of my favorite accusations is, oh, you don't use that many muscles when you're riding a horse, you're just sitting there. No, you're moving every single muscle in the core of your body to balance as the thing you're sitting on is moving in all sorts of different ways. So it's that concept of staying in equilibrium, staying in balance. But then when you start applying it across all the sciences, you find things like a balloon is something that's in equilibrium because the gas inside versus the elasticity of the balloon versus the air pressure outside, all these different forces are all in balance so that the balloon is neither shrinking nor exploding.
Now, what are some classic situations in space astronomy where equilibrium is really coming into play, and it's that loss of equilibrium that causes dramatic changes?
I think probably the one that is most important may be hydrostatic equilibrium in stars. This is, of course, a personal opinion. I'm sure someone else out there will say, no, something else is much more important. But without hydrostatic equilibrium in stars, they can't balance out to have nuclear reactions. With a star, you have the gravitational pressure that is causing the outer part of the star to try to collapse inwards, getting balanced by the light pressure pushing outwards from the core of the star. And it's this balance essentially between light pressure and gravitational pressure that allows stars to have such hot, dense cores that they can sustain nucleosynthesis.
Sorry, Preston, if there's someone outside, I'm just going to close my window.
Okay. That is the strangest interruption. There is someone outside my window at night watching us
just
record.
a neighbor. No, just a neighbor who's like, talking loudly in their backyard. It's just coming into. I can see it in my recording. I'm like, oh, Preston's going to kill me. So
sorry, Preston.
Right. So, and when we first sort of talked about that, and when I first started to understand this concept that it's the light pressure.
Yeah.
From within the star that is what's counteracting the gravitational pressure, that blew my mind.
Yeah, we generally call it radiation pressure, but the word radiation masks the fact that no, really, it's light. It's just light. It's in all sorts of different energies, so not all of it is visible. Some of it is quite deadly, but it's the light that is supporting the outer layers of the star.
And I think that original balloon analogy that you used at the beginning is really perfect because in the balloon, you've got the air molecules, bouncing around inside the balloon, and that's balanced against the elasticity of the rubber of the balloon.
And the pressure outside the balloon.
And the air pressure, right? Yeah, probably more so the air pressure, but
yeah.
But with the sun, it's the photons of light bouncing around inside the sun, pushing against atoms.
Yeah, and gas pressure does play a role, convective forces play a role, but by and large, it's that balancing between light pressure and gravitational pressure. And as the star switches fuel mechanisms at various points in its evolution, as it goes from burning hydrogen to burning carbon, there's helium in between those. As it goes through all of these different burning stages, it has to readjust to a new equilibrium as the temperature that's needed in its core and the density that's needed in its core to burn these heavier atoms is different. So every time it changes fuel source, it has to re-equilibrate. This is a show of words I can't pronounce well.
Equalize, equilibrate, is that the word?
I think so.
We can just make up a word. Equilibrify.
We're going to verb it. We're just going to verb
Right,
it.
we're going to verb it, yeah. Right, so you've got the situation, and and this is going on in the sun right now. The sun is slowly heating up because it's using up this hydrogen helium fuel in its core, and that's causing it to actually expand a little in the core, more light pressure, and it's kind of, it pushes itself a bit out of equilibrium, but then there's only so far it can go, and the gravity is pulling it back in, and so ends back in the spot.
My favorite case is in variable stars, where they're in a periodically stable equilibrium. And this is simply because they have a outer layer, often of helium, that as the star starts to hit a new equilibrium point, it ionizes all the helium. So the energy goes not into pushing out on the star, but instead into ionizing the helium. But as it continues to expand, as momentum carries it past an equilibrium point, it cools off. And the helium, then the energy as it collapses goes into neutralizing the helium. And so you keep ending up with this push and pull as the helium ionization and neutralization plays a role in the pulsation of the star. That was extremely simplified.
And it was very rhymey too, though.
It was.
Yeah.
So oversimplified and rhymey describes that description of variables.
And if as we've seen, like with supernovae, when the light pressure goes out, when the supernova has gone and converted all of its elements all the way up to iron,
you have a sudden lack of equilibrium.
Right, you have a lack of light pressure.
And in that case, when you wreck the equilibrium, when you pull the chair leg out and the force free body diagram is no longer in balance, the outer layers of the star collapse down, undergoing magnificent nuclear reactions as they go, and explosions occur.
Kaboom.
Kaboom.
And in the other way, in the red giant star, that's when really the light pressure takes over, right?
Well, and you, depending on what stage you're looking at, you can have a helium flash when a shell of helium suddenly ignites around the core. All these different things, or rather, you end up with a helium flash in the core as you have a shell of hydrogen burning. All of these different things can lead to the system suddenly changing in radius to balance everything out. It's similar in ways to what happens when you change the temperature of gas, for instance. If you have a balloon and you heat up the balloon, the air inside of it is going to expand. The velocities of the gas increase, the pressures of the gas against the walls of the balloon increase. And so in order to compensate for this changing temperature and this new pressure inside, the entire balloon expands. But if it expands too much, it'll overcome the elasticity of the balloon structure, and boom.
So I think another great example of this is the hydrostatic equilibrium that planets and moons and such face. And if they don't have enough mass, they can't pull themselves into a sphere.
Yeah, this is gravitational hydrostatic equilibrium on a different scale and in a different way. So in this case, when you have small bodies, the chemical structures, the everyday bonds between the minerals allow asteroids that look like potatoes. Basically, you have a chunk of matter, it gloms on, and yeah, gravity plays a role, but at a certain point, they're also held together through chemistry. It's like when you're building a sand castle on the beach. The shape of the sand castle is determined by the individual stickiness between the molecules and the particles of sand. Now, as that object gets bigger and bigger and bigger, the gravity that's trying to make everything round, to make a surface with a equal gravitational potential everywhere on the surface, that gravitational pull towards an equal potential surface will start to overcome the chemical bonds between the molecules, and this is where you get landslides This is where Earth can't have mountains as big as Mars can, because on Earth, if you start building something like Olympus Mons, gravity is going to flatten it as our gravity seeks to create an equal potential surface.
Yeah, from what I understand, like Mount Everest is pretty much at the
Yeah.
limits of how big of a mountain that we can actually have here on Earth. And it's no
And
surprise that it's the biggest mountain on Earth.
exactly. And over time, it will wear down and new mountains will emerge, and we're always going to have that limit to how much forces of gravity can bend things held together through chemical properties, and gravity won't squish them back down.
Now, where's that line? Like how big does an object have to be? How much mass does it need to have before it's likely going to have that hydrostatic equilibrium?
The asteroid series is about the limit of what we're looking at. So it's a reasonable fraction of the size of the moon, but Vesta comes close. It's fairly round. So the largest of the asteroids are approaching that stage, and then Ceres, the largest of the asteroids, is a dwarf planet, and
Right.
it meets the criteria by being in hydrostatic equilibrium.
So I wanted to sort of go another direction and talk about something that's quite exotic, because again, I love these opposing forces. So for example, like a neutron star.
Uh-huh.
Right? You've got this situation. Once again, it's gravity pulling it in. It always seems to be gravity that's doing the inward force. But now you've got,
Neutron.
you've got neutrons that are pushing back.
And it's a degeneracy system. So with a white dwarf, you have an electron degeneracy pressure. This is where it's the force of the electrons against each other, as the Pauli exclusion principle prevents atoms from sharing the exact same spin and energy level. So all of the electrons have to configure themselves exactly right in a white dwarf so that they don't defy the exclusion principle. And in this process, they form basically one solid set of orbitals throughout the entire white dwarf, and it's the electrons getting as close as they can without breaking the rules of physics that essentially supports the white dwarf.
One big diamond, right?
That's when you start looking at the carbon atoms in a carbon-rich white dwarf. Now, when you put too much pressure on that degenerate electron gas, those electrons and the protons in the atoms that they were surrounded by end up joining forces, and an electron plus a neutron, an electron plus a proton put tightly enough together is going to produce a neutron, a positron, and a neutrino. And positron flies away, neutrino flies away, and what you're left behind with is a neutron star that is, in this case, held together by the neutrons getting as close as they can before, in this case, other forces of physics are defied.
Right. Well, I mean, it's the gravity pulling it together. It's the neutrons defining the limit of how small and how big this object is going to be.
And in this case, you have the neutrons getting together pretty much at densities not too different from what you have in a core of an atom. And the strong and the weak force are defining what happens when you create a neutron star. And it's when you break down those specific rules and the neutrons get smushed together that we end up with an exotic matter we don't even know what is, and an object that we call a black hole.
Right. And so if the gravity just is too much, then even the neutrons can't sort of keep it in balance, and it just turns into a black hole. And I guess the thing with a black hole is, I mean, do we know of any force that could be pushing against the gravity of the black hole pulling inward?
No.
Right. And so that could be this sort of a runaway limit at that point, right?
Well, I think trying to speculate anything we can't really get away with at this point. It's a black hole. Physics breaks down as we move inside. I know you like to make things up. But we can't define a form of matter that would exist at sufficient densities to explain black holes. Some people call it a quark soup. Other people say we don't know. Other people make up stuff like going through to other universes. No, that's not what's happening.
Right.
So we just don't know. it's part of what makes science exciting. There's still things left to learn.
And I think, to go sort of to flip this whole conversation around, I mean, if we imagine, what is the breaking point, or at what point does the gravitational force, it's too strong, there is nothing to push back against it, and it just starts to collapse beyond what we could really understand. On the flip side, the universe has figured out, or has, surprised us with dark energy as the opposite situation, which is a repulsive force that's seemingly continuing to, expand the universe beyond gravity's ability to hold it back together.
You have to be careful, because we don't know if it's a force. We don't know. We know the effect that dark energy has, and the effect that dark energy has is it acts like a pressure. So it could be that dark energy is energy getting injected into the system. It could be that it's an actual field that there's all sorts of stuff we don't know.
Sure, but I think the sort of the outcome is that the universe itself isn't in equilibrium.
That's true.
Right.
No, we are not in equilibrium as a universe, and that's disturbing. But
yeah,
within the universe, it's really kind of awesome how the entire tale, from the way stars are formed to the way they die, is one of our own astronomical punctuated equilibrium. And in biology, they talk about punctuated equilibrium in terms of evolution, and how plants and animals change to fit a variety of niches. But when we look out across the universe, what we see is, well, because things weren't perfectly smooth after the Big Bang and after the formation in the cosmic microwave background, because we had a patchy distribution of matter, it was able to find places that eventually came out of gravitational equilibrium, and in this case it was gas pressure versus gravitational pressure, and the gas collapsed down to form stars. Those stars over time went through their own phases of different levels of equilibrium, as they went from burning one fuel to burning another, to sometimes exploding or collapsing. All throughout our structural evolution, we've seen galaxies collapse down into formation. We've seen systems that became made into spheres due to disk-like things collapsing, and everything we have is the result of two things getting out of equilibrium and creating a new thing in their wake.
Right, right. And so I think one of the last sort of places where we see equilibrium is just in orbits, right? Again, with gravity pulling things inward, but then we have this, centripetal force as things are going around in circles or in ellipses around these objects.
The way to think about it is, centripetal force is one of these artifacts that exists in appearance but gets messy when you try and define its reality.
Yeah, momentum.
What is actually happening is you have an object that is trying very hard to move in a straight line, and there is nothing slowing the speed that it has, but its path, its velocity is changing because its direction is changing. So gravity is working to constantly change the direction of an object that is moving at a speed that, because orbits end up being ellipses, may change as the object gets closer or further from the object doing the pulling. But the bulk of what you see with orbits is that direction ever constantly changing, as the object's getting yanked on in a straight line.
Yeah, so. And I mean, there's a great example, right, of how to actually sort of mentally get yourself to orbit, where you shoot, like a cannonball out of a cannon, and the cannonball shoots a few hundred meters down range, and then you shoot it harder, and it goes further, and you shoot even harder, and eventually you get it hard enough, and it's going around so far that it never hits the ground. It just keeps going around in orbit. And so you've still got that gravity pulling this cannonball inward, but then you've got its momentum trying to escape, and it gets held in this perfect balance.
Its velocity is trying to stay constant. The force is changing the velocity as it accelerates it along a curve. And yeah, gravity always wins.
But I always think about the orbits of the objects in the solar system. Like, think about how the planets are going around the sun in the same way for billions of years. But if there was any instabilities in that orbit, if they weren't in equilibrium, they would spiral inward and crash into the sun. They would spiral outward and escape from the solar system. They would crash into other objects in the solar system. Like,
What I love is what you're thinking about is on such a limited time scale. The
yeah,
planets have orbits that are in equilibrium for the time scale of the human race. But in the past, we know they weren't in
yeah,
equilibrium. We know that Saturn and Jupiter were in a resonance that flung Uranus and Neptune out much further than where they formed. We know that there is a period of heavy bombardment that was triggered by all of this as things careened all over the inner solar system, including an object roughly the size of Mars that hit Earth and generated our moon. What we perceive as orbits in equilibrium simply means that right now, nothing bad is apparently going to happen. But the orbits are constantly experiencing small degrees of change. Mars in particular, we can see how its poles migrate over time. So there is constant change going on, and the planets aren't in a true, complete equilibrium.
yeah. Take a look at, say, Phobos, right? The Mars moon that's not in equilibrium,
And eventually it's going to crash into the
yeah, it's going to
surface.
get torn up in the next 10 million years or so, and then get sort of impact the surface of Mars.
And our own moon is migrating away, but the sun will blast us to smithereens before it has a chance to escape.
I would love to see some kind of simulation of just like a time lapse, a really sped up time lapse of like the future, the past and future of the solar system, to see just like the positions of all of the planets and the as they moved in and outward, and things disappeared and moons drifted away, and and then the sun goes into its red giant phase, and you see what impact that has, and it turns into a white dwarf, and then just run that clock for trillions of years as whatever planets are left continue to orbit around the sun. That would I think that's what you're getting at, right? As you said, we have this sense of scale of just human history, but in fact, if you play it out across the billions or trillions of years, then there's many more movements that are happening.
Yeah, and creating that animation that you want is actually something that's not too difficult, but it's the type of thing that's extraordinarily hard to get funding to do. And you're really looking at one beleaguered PhD level astrophysicist working very hard
Doing the
for a
math.
year, and then a programmer or two doing the graphics. So now you're looking at 1 year salary for 3 people. So your pretty animation would probably run about $300,000 once you factor in medical insurance and university overheads.
Right.
So if you
Right.
find me the money, I'll make
Oh,
you the animation.
awesome. Okay. All right. I will not. So, but thanks for the offer. We'll just fake it instead. Cool. All right. Well, thanks a lot, Pamela, and we'll talk to you next week.
Okay, sounds great. Sorry, that was just way too much fun to point out the actual producing that animation. It's like, yeah, I could do that. No, I don't have the
No,
time.
no, wait,
The
wait.
cost.
Yeah,
Oh, wait.
yeah. Come
Yeah.
on. It would like go viral. Everyone would be like,
Yes, but again, that's the internet famous, which
yeah,
is
I know,
not
I
the
know, I know.
same
That's the thing.
thing.
We'd be like, hey, check out this really cool animation that Dr. Pamela Gay and her researchers created, showing the past and future of the sun. And then, the reality is, of course, it chewed up, a year of your life, and yeah, yeah,
Yeah, I'm destitute and living on the sidewalk.
yeah, exactly. And all you could do is just mumble about orbits and red giant stars. Yeah. No, that'd be great. I look forward to someone coming up with that. Cool.
Seriously, I know exactly who I'd hire to do it
Oh, really?
if we had the money. Yeah.
Yeah. Okay, so we're gonna record again tomorrow at. Let me see if there's any
Early.
quick questions. Let me see.
I looked at the time and it hurt.
Steve Perry says, "Great discussion, Fraser. Say hi to your neighbor for us."
Your stalker neighbor.
Oh, my stalker, right, right. Of course, my neighbor having their party outside. Yeah, I was like, what? Wait, what? That's it.
So we're
Dex
recording
Luthor's.
tomorrow at
Yeah.
8 a.m. No, we're not recording at 8 a.m. I'm
No.
prepping at 8 a.m.
Yeah.
Pacific. We're going to
Yeah.
start recording at, wow, there was a
9.
long time set aside there. Okay,
I
yeah,
know.
9.
9. So yeah.
Yeah.
Okay, great. I will put that an event for that, and I will pitch a couple of topics at you tonight, and then I'll
Okay.
make the event. So we'll talk about this off air.
Okay. That
Unless
sounds
someone
good.
watching has a suggestion for a topic. No, I don't see any. Not that I give them very
Seriously,
much time.
Okay.
People want to know how I
one
grow
is
a thick
watching.
beard. Are you kidding? This is like 2 weeks, 3 weeks. Yeah.
Fraser has Instabeard. It's
I have
really kind of
Instabeard.
amazing when you go on vacation with him.
Yeah, I know.
It's like him and Adam Levine.
People are like, oh, I like your beard, but it's actually a pain. It's actually better to have it shaved because it's just kind of itchy and hot, and it's summertime. So I'll probably be getting rid of it again in a couple more weeks.
It does work well in all your videos. I will give you that.
Yeah, there we go. Okay, cool. All right. Well, thanks again, Pamela. Thanks everyone for watching. Sorry we kind of messed up the time on this, and we just sort of threw this at you at the last minute. Get used to it this week, but I'll try and put more and more of the events in the listing. So, but they'll all show up in the feed anyway. You can watch in the archive. Nobody will be mad. Somebody wrote a really sad review on iTunes. It was like something. They gave us 1 star, and they're like, because of our bad schedule, we've destroyed all of our credibility and goodwill that we've built up.
We do this for free.
I know. Refund in the mail. I sent him his refund. Okay. Are you in a state of?
I'm waiting for my thing to rename
to...
it so that I don't copy over what we did earlier.
Probably best.
Yes, it's working on it.
It's 303.
Yes, that was what I was correcting.
Good.
Yeah. No, it's for those of you who don't know, this is something I was sharing with Fraser before all of this gets started. We've reached the point of internet celebrity, which is not the same thing as real celebrity, because real celebrities get paid.
Right.
We've reached the stage of internet celebrity where we're getting, hey, will you donate to our Kickstarter? I even had one friendly soul who had clearly no understanding of what state university professors are paid ask if I would help buy him Google Glass. And no, we do this for free, and neither of us have well-paying jobs. Fraser is a journalist. I'm a state university professor. So unfortunately, our need to occasionally earn a living gets in the way of our recording.
Yeah, exactly. Yeah, and it really does. I mean, if we've got to buckle down and get through the work that pays the bills, that's what we have to do.
Yeah. But I now have GarageBand happy.
Oh, good. Okay, so you're ready to record?
I am.
Okay. Let's get this party started then.
Okay, I'm pressing record.
I am also pressing record. All right? Can I start?
So? Yes.
Okay.
You're good.
All right, here we go. Astronomy Cast, episode 303 for Monday, April 22nd, 2013. Equilibrium. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hi, Pamela, how you doing?
I am doing well, but my recording just stopped.
What? I have to do this again?
I'm sorry.
Okay, I'm ready. Should I stop my recording?
Yeah. I apparently have more things open than...
Oh, she's like, I'm going to share my calendar with you. And I was
well, you were proposing all of these things, and I know,
and now you just shared me your calendar, and I just stared at it in shock horror and just cried. Oh, it's madness.
No, madness was the tornado on Friday.
Yeah. Okay, cool. So let's. Are you in mono-ish?
No, that would have been intelligent.
Okay. Yeah, and if you want to post any comments, questions, feedback, we can probably answer some questions afterwards, although I will probably have to go run and parent after this. So yeah. And so this is probably going to be a very short episode. In fact, probably a lot of these sort of one-offs are going to be short episodes.
But we will be caught up.
Yeah, which would be great. Everybody will be happy. So if anyone has sort of no idea what's going on here, we are recording a live episode of Astronomy Cast. Specifically, we are recording a catch-up episode of Astronomy Cast. So when I start up this episode, you're going to hear me say that it's episode 303 for Monday, April 22nd. And that's because
It's not April 22nd.
It's not. It's because we're about 8 weeks behind. So
it's June 2nd.
It is June 2nd. So we've got about 6 episodes to go to catch up after this, and we're going to be getting a big chunk of them done today. No, sorry, this week, not today. And then we're going to get a bunch more done to kind of get ahead because you're going to be gone in July. So
yeah.
So we've now got our good buddy Courtney is sort of whipping us into shape, making sure that we sort of are able to manage our schedules.
At even Miss Array.
Yeah, even if it's at very strange times. So yeah. All right. So
and if you ever want to traumatize Fraser, show him my calendar.
Yeah.